everyone, this is Teacher Colleen and welcome to our physics class. For today's lesson, we will be discussing the first law of thermodynamics. What is thermodynamics, by the way? The term thermodynamics is derived from the Greek words thermos, meaning heat, and dynamis, meaning power or force. But before we continue our lesson, let me share to you first our objectives. Our first objective is to state and explain the first law of thermodynamics. And our second objective is to apply the law to various physical processes and daily life experiences. For a while, let me drink some coffee. Oh, it's very hot. I can feel the heat outside the cup. Okay, I'll just drink this after our class. Now, what do you think is the first law of thermodynamics all about? By definition, the first law of thermodynamics states that energy cannot be created nor destroyed in an isolated system. The total amount of energy remains constant, although energy can be changed forms, such as from kinetic energy to thermal energy. The first law of thermodynamics can be expressed mathematically as delta U equals Q minus W, where delta U is the change in internal energy of the system, and Q is the heat added to the system, and W is the work done by the system. What is internal energy? Internal energy, or delta U, represents the total energy within the system, including the kinetic and potential energy of the molecules. What is heat? Heat, or Q, is the energy transferred to the system from its surroundings due to the temperature difference. And what is work? Work, or W, is the energy transferred when the system does work on its surroundings. In order for us to understand the first law of thermodynamics in an easier way, let us have this example. Have you tried boiling water in a pot? What did you observe? How can we explain this law in boiling water? Let us identify first the parts of our system in this example. The pot is our system, and the outside of the pot is our surroundings. Initially, the internal energy of the system is low. When heat is added to the pot, the internal energy of the system increases, making the water to boil. Since this kind of a system is an open system because we allow the volume to expand, thus, work is done by the system to the surroundings. How can we say that work is done? Now, try to look at closely to the lid of the pot. Isn't it moving? Yes, it is, because the gas molecules inside are exerting pressure to the lid. Thus, they are doing work. Got it? Very good. Now, let me think of another example. A refrigerator. A refrigerator extracts heat from its interior, powering its internal energy, and expels it to the surroundings, while work is done by the compressor. If you're going to touch the backside of the refrigerator, you can feel that it is hot. Why? Because it releases heat from the inside and it goes to the surroundings. What about you guys? Can you now give another example wherein we can apply the first law of thermodynamics? Before we end, let us summarize today's lesson. The first law of thermodynamics states that energy cannot be created or destroyed, only transformed from one form to another. This principle is known as the conservation of energy. Internal energy, delta U, of the system can change due to heat transfer and work done. When heat Q is added to a system, it increases the system's internal energy. Work, or W, can be done by or on the system, affecting its internal energy. The first law of thermodynamics is often expressed as delta U equals Q minus W.
Daily life applications of the first law of thermodynamics are boiling water, refrigerator, and many more that involve transfer of heat energy.
Now let me check my coffee if I can drink it already. Yes, it's no longer hot. I know you can already explain why. Would you like to learn more about thermodynamics? See you next meeting. Thank you for attending our class. Goodbye.